Hi, my name is Masroor Husain and this video is the full-length presentation of my final project for the Computer Science E-90 Cloud Computing class at Harvard. The project is about rapidly building an Oracle 12c database on Amazon Web Services. This video assumes that you as a viewer are already familiar with AWS credential settings with the key pair that allow you to launch a SSH connection from your desktop to an EC2 instance on AWS. And these are some of the sources I use to build the Oracle database environment on the Amazon cloud. Here is a high-level overview of what we will cover in this video. We first build an average class T2 small EC2 instance with 3 EBS volumes. We choose to build from an AMI, which is an Oracle Enterprise Linux 7.6. We purposefully choose AMI with OEL 7.6 as it offers a very convenient package given by Oracle Corporation for making OS level changes required for the Oracle installation. We will format and mount the volumes. Then we will fulfill all the OS level requirements like updating OS and installing some utility packages, and then we will run the Oracle provided package for making OS level tweaking for the Oracle software. Then we will fix the Oracle security for the Oracle user that this package will create. We will be uploading Oracle software binaries to the EC2 instance. And then as user Oracle, we will install Oracle 12c Release 1 on the instance, create a starter database, also verify some basic elements of the new database to make sure it's working fine. Lastly, we will try to scale the EC2 instance vertically up from T2 small to T2 large to ensure that Oracle database remain intact and can benefit from the increased memory and CPU resources. So next we will go to the AWS console and start our activities. So we first begin with the setup of an EC2 instance using the latest version of Oracle Enterprise Linux OL 7.6 from an AMI, that is Amazon machine image, with a couple of extra EBS volumes for conveniently installing Oracle software and creating database. Okay, so let's launch an instance. And go to the community AMIs, search for OL 7.6, select this one, the latest AMI for Oracle Enterprise Linux. For the machine type selection, instance type selection, we will choose the S2 small. This does not qualify for free tier, but it is pretty inexpensive, especially if you shut it down on a regular basis when you're not using it. So we click on next. Here we pretty much take all the default settings. So we move on to adding storage. So we click on next, add storage, and here we will be adding 2 more volumes. So add new volume of 5 gigabytes and another one for 20 gigabytes. The 5 gigabyte will be used for swap file, and the 20 gigabytes will be used for holding the Oracle media, software media, the installation, and the Oracle database also. So click on next, add tags, and here we will name our machine to be Oracle server, and then click next, configure security group, and we will be using an existing security group that I have already created prior to launching this video, that is tailored specially for a database server. And as you can see that I have allowed the SSH connections on port 22 from anywhere, and another TCP connection on port 1521. The port 22 connection will be used by our desktop secure shell terminal, and the 1521 port TCP connection will be used by listeners that will be connecting to Oracle database. This is not a good practice to open it to the whole world, but this is actually not a production system, and this is only for a demo. But in production system, we don't want to open up in this manner to the whole world. So review and launch. Okay, so we click on launch one more time, and I already have a existing key pair that I have created for this particular region of Amazon. Your key pair for credentials basically are regional specific. So I have named that as Amazon East, which is the region I use. So I will be using this. Launch instance. Okay, so clicking on view instances, and we need to give this a couple of minutes to start. So I'll pause the video. Okay, so the instance is created and it's up and running. I also went ahead and associated an elastic IP address, EIP, to this instance. So even if it goes down, comes back up, its IP address, public IP address, does not change, and will be very convenient because we have to continuously log on to it while it may be rebooted a few times in the future. So let's try to connect to this instance from our terminal. I use MobaXterm to connect to EC2 instances, which I find very convenient. And I have already created a couple of connections here based on the EIP address. So I will be logging in to this instance as EC2 user. As you can see here, user is going to be EC2 user, which is the default user for a new AWS instance. So I'll double click here. Okay, so I'm in. So first we need to update all the OS related packages on this instance, and we'll run a sudo yum update command, which will run yum update as with root privilege, and the -y will not prompt us for a question and will proceed and take all the answers as yes. And next we need to install utilities which are very useful, such as the wget, zip, unzip, and perl. So as you can see at the bottom, I have this. Oh, I pasted the wrong command. So let me correct this here and paste the right package that I wanted to install. The package name is Oracle RDBMS Server 12c Release 1 pre-install. So it's pretty meaningful name. So we'll go ahead and run this package, which will make all the OS changes related to Oracle Server install, and may create some accounts such as Oracle user and O install group. So let's run this. Okay, so say yes. Okay, great. So that's done. So our next step will be formatting and mounting those extra disks that we had added during the creation of the instance. So let's examine what's out there on our server. We'll run this command lsblk that shows that we have the xvda already mounted as a root file system, but xvdb and c need to be mounted with proper names. So we'll just format those two first. So this is the sudo command makefs to format the first EBS volume. That's done. So we will format the second one as well. Okay, now that the formatting is done, we will work on the swap file creation process. So we will type a few commands to get the swap file in place. Sudo make directory swap file 1 mount. So xvdb will be used for the swap file. Okay, so let's mount those two file systems that we had formatted. Actually, there's only one remaining, which is the xvdc one. So we will mount it to a local /uo1 mount point using this make directory command. And this mount command. Right, so let's look at the file systems again, and so we can see both swap file and the uo1 are correctly mounted. So now we need to enable the swap file on this swap file system we have mounted. For doing it, we have to run a bunch of commands, and I put those commands conveniently in the script called swap.sh. So let me show you how it looks like. So first we will run a command to see how much swap space we have available right now, and as you can see at the bottom it says swap 0. So we have to run these commands basically to initialize the swap file using the dd command, and then change the ownership of file systems for the swap space, and then eventually we swap on, which is basically enabling the swap file itself. So I will be running all of these commands together to save time here. So all of these 5 commands will run one after another. So I'll copy all this and I'll paste it in my screen here. Okay, so I had paused the video because the dd command was taking a while to finish. It took about a minute or maybe two to finish, and all of the commands ran successfully. So let's try and check the memory again for the swap space, and as you can see at the bottom, that swap is showing about 3 gigabytes, 3000, roughly 3000 kilobytes. So we have swap space available now. So for the two file systems we added, we want to make sure that even when the box or the instance restarts, they again get mounted automatically to it. So we'll make a change to the fstab file. Um, we'll first make a backup of fstab that controls automatic mounting after the box is bounced. So we'll make a copy of this file, and we'll vi this file and go to the last line and add a couple of extra lines for those two mount points. Make sure there's no spaces, and then save and exit the file. So we run the sudo mount a command just to make sure that fstab is in correct shape and will work when needed. Now let's change the ownership of the UO1 mount point that we had created earlier to Oracle and the O install group. So user Oracle and the group O install will be the owner of this UO1 file system. So we'll do sudo Oracle install UO1. So if you look at the UO1 file system, it will be owned by Oracle and the O install group. So our next step will be to change the hosts file for the instance so the instance can enable self lookup based on its own host name. So let's find out the host name of this instance. Copy this in your buffer, as you will be pasting this very soon in the host file. So we'll say sudo vi etc hosts, and what we need to do is on the first line add this host name to enable the self lookup based on the host name itself. Save this file. And next, let's change the password for the user Oracle. So we'll change its password, which will make life easier going forward. Okay. And next we want to enable Oracle's user so it can log on its own from our desktop instead of logging on as EC2 user, because Oracle user will be used to install the Oracle software. So let's try to log on as Oracle. Okay, and let's see if we are landing in the right directory. Yeah, so we are landing in the Oracle home directory. So for getting Oracle logging on directly, we need a public key installed in this Oracle home directory. So I have created a short script to do that to save time, and basically this is the script right here, and we will be running the script which basically creates a .ssh directory and copy the file, the public keys over, and do some cleanup. So I will run all of these commands. So now these commands ran successfully, so we will try to log on directly from the MobiX term as Oracle user to our instance. So I need to, and I already have a session here that I can use that will log in as Oracle directly, as you can see. So I will double click on this and check it, and yes, we were able to log on successfully. So Oracle is now independent of EC2 user and make connections on its own and install Oracle. So now we need to switch our gears and download Oracle software, which is Oracle 12c Release 1 for Linux 64-bit from the Oracle's website technet.oracle.com. The software is comprised of 2 zip files. Each file is about 1 gigabyte in size. So downloading will take maybe 10-15 minutes, and then uploading it back to the instance on EC2 will take another 5 to 10 minutes depending on your network speed. So I've done all that to save time, and you would like to store those files under UO1 software directory where I am at right now. And once you transfer those zip files over, you need to type unzip and then uh, unzip one of these at a time. So unzip the first file of the 2.zip and then unzip the second file as well. Unzipping will take another couple of minutes, and I've done that as well. And after unzipping, you will end up with a new directory that will be created as part of the unzipping called database. So this database directory is going to contain the unzip media for the software installation that you need. So you have to go in this directory, make sure you're logged on as Oracle, and look, let's examine the directory. Uh, Basically, the installer for Oracle software is called run installer. So we will be running this right now. So kick this off. The installer is going to pop up an X window, which is actually now it's actually a Java window, pop-up window, which will come up in about a minute or so. That will show you the details of the software you're trying to install. So when you see an icon showing at your desktop space, you can click on this pop-up window and it's going to show you this Java window. And the way you install this is basically you pretty much pick all the defaults except for the first page. I think that's probably one of the few exceptions that you would uncheck this wishing to be receiving security updates from Oracle, because it's just like a test environment. You don't want to provide them your email address either, so click on next. And each of the steps will take about 20 to 30 seconds. So I'll try to fast forward as much as possible. When it says you have not provided me an email address, just say yeah, that's fine. So keep moving. Okay, on the next window it says create and configure a database as well as one of the options, which means that install the software in the database. So you would say yes. You would select this. This is also a default. Okay, next is the desktop class. You will pick that as well. Okay, next window will show you the locations where the software will be installed, which is fine because you already have UO1 mounted correctly with enough space, and the database name will be ORCL, and you want to create as container database. So you basically choose all the defaults and click next. And one more thing you need to fill out here is the password for the administrative account on the ORCL database. So you have to set up a password, strong password. so I need to try it again. Okay, and then click next. Okay, choose the default here for the inventory location as well. Okay, so the installer runs all the verification, making sure everything is okay, and shows you a final page where you can verify everything's fine, and then click on install. So now it's in a process of copying files from the software media directory UO1 software over to the Oracle home, which will be under UO1 app Oracle product 1210 db home_1 directory. This process may take about 10-15 minutes at least. So the installer will pop up a window asking to run some scripts as root access with root access. So you have to go back to your EC2 user session if you don't have it open. I already have it open, so I'm going to just run the command straight. Sudo uo1 oh, I'm in the wrong place. Let me go back to my EC2 user session. So I will kick off my EC2 user session, a new one, and run the command here. Okay, so that went through fine. And the second command is again another sudo and you basically take all the defaults. Okay, that also ran successfully. So we can go back to our previous window, the place where it says run all these commands as root, and come back to this particular window and click OK. Don't try to click on other windows yet, just focus on this one for now. So click OK. So once you click OK, it's going to continue on to other items, but I think the main installation for Oracle in terms of the files, binary files needed, are already copied over, and it's going through a process of doing the wrap up, which is the Oracle network configuration setup and so forth. And it will pop up in an extra window on top. If you notice on the left side, there's a database configuration assistant window that was popped up on top of the existing window. This is a window this will actually create the database ORCL, which is a very long process by itself. So software installation is about 20 minutes, and another about 20 minutes just for creating the database, because it has to initialize all the files on the file system. There are many files it has to initialize, and then it has to run data dictionary scripts from Oracle, which take actually quite a while, because these are SQL statements that all have to run in proper sequence. So that's why it takes a really long time to run, because the data dictionary of Oracle is extremely large in size. Okay, finally it comes back with another window with the confirmation that everything was done correctly, or RCL was created successfully. So just click OK on this third window, and notice that it again went back to this original installation window, and it's continuing on. At the top it says installation of Oracle database was successful. Only when you see a close button here, don't try to X out of this window. Make sure to click on the close button so you have a clean installation. So at this point we have successfully installed the Oracle database software and created a new Oracle database on this EC2 instance. So we'll go back to our installation window with the Oracle user on it. Notice it's still showing the run installer command that I typed previously. So I will press just a enter and goes back to the prompt. So let's check out this new environment, but before we get into our database, let's fix a couple of files that are used for listening to database connections. So for that we need to fix the host name in those files. So let's find out the host name one more time and copy this, because we need to replace the local host uh, string in some of the files with this particular host name. So we will go into the database directory for this version of software we have installed, and there are a couple of files that we want to modify. The files are listener.ora file, and you want to replace the local host with that value of the host name that we actually have. So let's save this file, and there's another file, tnsnames.ora. So listener.ora is used for the server to listen for incoming connections, and tnsnames really is like a pointer. It's like a directory service for database. So it says that orcl equal and then it has details of the database. So we will replace the server name here as well. And notice that here it says port equal 1521, so it is actually going to listen on the port 1521. That is why we created this the security group when we were creating this instance earlier. So let's stop and start the listener process that we just because we fixed a couple of files, so we need to restart the listener process that listens to connections coming in to the database, and we can do it using ls and rctl stop. Oh, I need to first get the environment variable set for this database. So Oracle provides a file called ora-env that you can actually run just by saying dot space ora-env and then press enter, and then provide the Oracle SID, which is the database name, and we know it's orcl in our case. So, and then when this has been run, it will set up some environment variables. So when we type the listener stop, again should work, and it did stop the listener, and we will start the listener again. And next we go into the database and test drive it. So SQL Plus is the utility to log on where you can run SQL type commands within the database, and we log in as the sysdba, which is the highest privilege account. So let's look at the name and the creation date of the database. So we'll just say select name, which is database name, and created, which is the date the database was created from this special view. And notice it says orcl from today, and see for example the files that are associated with this database. So these are almost like 10 files of different types that are part of the database. So these take quite a bit of space actually. So we want to restart this database also. So we shut down immediate. Takes about 10 seconds and start up. And one more thing we want to verify is that database ORCL can listen to the incoming connections. So there's a TNS ping command, which is sort of like the normal ping for the OS, but it actually pings for the Oracle database to make sure that it can be reachable. So if you type TNS ping and then database name, it'll show you that you can it is listening for incoming connections on this host, and the last line should say OK, 0 milliseconds. So the OK means that it worked successfully. So now we are done verifying database health is okay and everything is functioning fine. The next section, we want to check to see if we can maybe try scaling up vertically our EC2 instance, so Oracle database can benefit from the enhanced machine in terms of the memory and the CPU that it will get. In order for us to change the instance type of our EC2 instance from T2 small to T2 large, that is the one with more resources, we are required to shut down the instance and then change its type by AWS. But before we do that, we need to really shut down the database so it can come down cleanly on its own and does not cause any problem with corruption, file corruption possibly. So I'm going to shut down the database. Okay, so our next step will be to go to the EC2 console and change the instance type. Okay, so I am going to stop the instance Oracle server. So I can change the instance type. Okay, now that the instance is down, we will change the instance type to T2 large. Which will easily double its memory on the instance level. Okay, say apply. And let's start this instance again. Okay, so the instance started up successfully and we are going to log back to it again. So I'm going to go back to my old window and click on restart session so I can log in as Oracle again on it, and we will change our environment to warcl, and then we are going to start up the database. So we can just run a quick top and look at the kilobyte memory right here, and it shows almost 8 gigabytes of memory. So there is definitely an improvement compared to, I believe, our previous 2 gigabytes of memory. So we went from a 2 gigabyte memory server to 8 gigabyte memory server within a span of maybe 10 minutes time it requires to shut down the database, shut down the instance, change the instance type, bring up the instance, start up the database again. So in a very short period of time, we can really vertically scale up our system very efficiently using the AWS technology. So just a quick wrap up of this full length installation video. is that we were able to install the Oracle software, which is a very complex piece of software, and also create a database within a day's worth of work. I probably spent a few hours on it, and if I were to do this on an on-premise system, it may have taken me, along with a lot of people, probably a few weeks at least. And if you include the time to order the server, that's another maybe a month or two. So we're looking basically we have gone from weeks or months worth of work down to about a day's worth of work on the AWS environment for running Oracle. So overall, I believe it's very efficient, and there's a lot of value in it.